what if we want to use a different method, the multiple regression? Here we will need more variables. Here I'll create a scenario where we have a factory that has part factory, part meeting room. And the utility costs are captured here for more weeks than we see here. I'm just showing you 17 weeks of the 30. And we also have data on how much production in units were made in the factory that week. And then furthermore, how many people were in there that week. So we wanted to estimate. The purpose here is we want to estimate what would it be for utility costs if we have 9,500 units being produced and 80 people in the building next week. How much would we expect our utility costs to be? And here what we're going to do is we're going to just experiment. We're going to start with, let's just try a linear with the people, and then a linear with the production. Then let's do a multiple regression with both. And we look and see which one is better at explaining the variation in this data. All right, here's the same data except in Excel. So we have utility cost, and then we have the people in the plant, in the building, and production in units. And let's start with linear regression and just do it with people. So we're going to go data analysis, regression. We're going to specify the y range, which is the dependent variable, what we're trying to explain, and we'll shade the utility costs, carefully getting the label all the way to the last data point. And then we're going to start with people. So let's go shade, again, the label of people down to last data point. And then we say, go. All right, so here we see an adjusted R squared that is pretty ugly. So we look at the other measures of goodness of fit, and we see that they're okay. So even though this function explains only 12% of variation, at least there is a positive correlation between the number of people and the utility costs. And this is the function that we would have. The intercept is 2907, and the people in the building would be 16.68. So let's say if we wanted the formula, we say, okay, how much will we spend in utility costs if we have 80 people next week? So it's the coefficient plus the cost of 16 per person times 80. So the answer would be 42.42 is the amount we would expect to pay if we had 80 people. That's for 80 people in the building next week. Okay, so that's our estimate. Now we can go back to the data and do the other variable. So let's go data, analysis, regression. Now instead of specifying X as people, we'll specify the range for production instead. And I'll just check to make sure the Y is okay. Yep, the Y is the same. And we can then say go. So what just happened here? Well, the adjusted R squared got better. We're up to 75. The significance is still below 0.05, as is the p-value. So that's okay. So this is better. So now we have this relationship. And we could say, if we have 9,500 units, what would be our production? So it equals, again, take the intercept plus the coefficient for the variable times what we estimate for that variable, 9,500 units. So this one estimates $5,056. Now remember that the prior one was 4,200. You know, they're different, but not wildly different. The final example is, let's do multiple regression. So again, data, analysis, regression. But this time the X range is going to include both people and production all the way down. So I shaded the labels and the data, and we check on Y. Y looks okay, and then we say go. And if we evaluate these results, we're now up to 84%. So okay, that's better still. And the significance under 0.05. The p-value for the variables are under 0.05. And now we have our formula. So if we said, well, what if we had 9,500 units and we had 80 people, what would the estimate for utilities be? So plus or equals, doesn't matter, the intercept plus the cost per person times the number of people, 80, plus the cost per unit produced times the units produced. Enter. So 5203 is our estimate. So the regression results would tell us that if we had 80 people and we made 9,500 units in that building next week, our estimate for utility costs is 5203, right? So now you see the beauty of a multiple regression, because we use historical data to create a formula that we can use now to predict what would the utility be if we had different numbers of people or production in that building. So summarizing this first video lecture, in economics, we looked at how the market works, the invisible hand. We looked at consumer choices and how they would act given different pricing. And then we also looked at suppliers, how they would act given different pricing in the market. Then we looked at the costs and profits of the firm as expressed in cost, volume, profit. And we looked at the cost behavior, fixed, variable, mixed, and step. And then we applied the scenario where there's only fixed and variable into a single product example of CVP to get to a break-even point. Then we looked at time value of money in terms of present value and future payments, both for single payments and for a series of payments, also known as annuities. And then we looked at some statistical techniques, such as how do we describe a data set in terms of the mean, the median, and a standard deviation. Then we looked at a tool, statistical tool called Regression, and we used both a linear and multiple regression to look at patterns and see if we could develop a formula to help us estimate the number in the future, right? So that is that for our video lecture. I will see you in class. What we'll do in class, by the way, is we're going to discuss these topics. We will not go through all these again in detail. And we'll have breakout sessions for you to practice your new skills. And then bring questions that you had from this video or just any questions relevant to the topic and bring them up in class. And finally, if you have something to share, maybe some experience or something in your past, please do so. Share it and we'll discuss that as well. So that's the purpose of this flipped classroom, for us to have space when we're together to do things in teams or have discussions. So see you in a couple days. Bye-bye.